So in our first system, okay, we have the tube of water, and we got the water wheel, and all right, so this is what we have here, and we want to show our energy symbols, and you got to pull this thing out right here to get the water to be started, and it actually tells you what type of energy it is by the color over here on the right. So your very first energy form is what? It's mechanical. So the water that's falling down, that is mechanical energy. So put that in your first blank right there. And then what does the mechanical energy actually change into? It changes into electrical. And guys, look, this is the way that energy is actually transferred. I mean, not necessarily, you don't get yours necessarily from a water wheel, but this is basically the way the energy gets to you in your houses and stuff like that. It has to start out as something that can be converted into electrical energy, which then can be converted into a number of different things. I mean, you might plug in your, I don't know, your dishwasher or whatever, and it produces hot water. You get thermal energy that's produced there. So mechanical changing into electrical, and then the electrical changes into what? Electrical changes into thermal because it's heating up the water. So that's going to be your last of your energy transformation. All right, now the next one, we have the sun, and we have our solar panel, and we still have the water. Okay, so what kind of energy do we have to start out right here? We have light. And what is it being converted into? Electrical. And what is the electrical being converted into? Thermal. Okay. And then what happens to the energy transferred when you have lots of clouds? So let's say that we have lots of clouds, like happens a lot of times. What happens to the energy? There's less energy. Okay, not as much of the light energy or the solar energy would be able to get through if you have a cloudy day. That's the problem with solar panels a lot of times. The sun isn't always shining brightly. All right, go ahead and flip to the next page. Okay, we got the tea kettle, and we got the water wheel, and we got the water. Okay, so as we heat up the tea kettle, all right, what kind of energy do we start with? Start out with thermal. We are heating the tea kettle, and it's changing into mechanical because it's actually turning the water wheel, or the technically steam wheel, if you want to call that, generator. And then what's it transferring into there? Electrical. And what else? Then it's going back into thermal. All right, now look at this simulation right here. Is this thermal energy 100% efficient? No, it's not, because a lot of this thermal energy is actually just floating up into the air. Okay, so not all of this thermal energy is actually being used to turn this wheel right here. So it's not a super efficient form of energy, but not every, really, some sources of energy are actually more efficient than others. All right, let's take a look at the girl on the bicycle and the wheel, and we got the water again. Okay, so she's turning, and what type of energy does she have right off the bat? She has chemical, all right, within her body, which is the same for you. So chemical transfers into what? Mechanical. And then the mechanical, you got to feed her every once in a while. You can't ride your bike forever. So what does the mechanical transfer into? Electrical. And what does the electrical transfer into? Thermal. Okay, so what kind of energy is converted to waste energy by the bicycle? Well, if you look right here, every once in a while, you will see one of these, and that is thermal energy that's flying away. So, anytime you have friction, like, bicycles have wheels, and you got things that are sliding past each other, so there's going to be friction. There's going to be some loss of energy that occurs. And then what force is causing the waste energy? It'd be a frictional force. So this was thermal energy. Technically, the thermal is what's lost. It's generated by the mechanical energy, so you can put either one there. And then friction is actually the force that's causing that. All right, and then if we set up the water and the wheel and the light bulb, okay? So right here, what kind do we have to start out with? Mechanical. And what is the mechanical transferred into? That is electrical. And what kind of energy is that transferred into? So some of it's thermal, and some of it is light. Okay? So the thermal is actually transferring into the light energy there. Now notice some of it stays thermal energy though. So light bulbs are not 100% efficient because you do have heat that comes off them, so you lose a lot of that energy in the form of heat. So, I mean, guys, if you think about it, and you'll think about this one day whenever you have to pay an electric bill, but you actually just waste a lot of the energy that you actually pay for because it's not actually going towards usable energy. Like let's say that you're using a light in the summertime, that light is going to heat up a little bit, so you're actually slightly heating up your house even though you want it to stay cool in the summertime. So, no process is actually 100% efficient in using it for the purpose that you want to use it for. Like for your car, once you guys have a car, you guys know what percentage of the gasoline that your car actually uses to move?
20%.
It's a little higher than that.
30.
A little higher than that.
75.
So most cars are somewhere in the 40% range. Now, there is going to be a range because, a diesel truck is not going to be as efficient as a Prius, all right? But there's going to be a range, but most cars are somewhere around 40%. So that means that like 60% of the gasoline you buy is just like heating up the neighborhood. All right, so what kind of energy is converted to waste energy from the bulb? Yeah, you're losing the thermal energy here. All right, go ahead, flip the page. So we have our tea kettle and the water wheel. And all right, okay. So the tea kettle gives off what kind of energy? All right, so that's thermal, which becomes mechanical, which becomes electrical, which becomes, so that's going to be thermal. We'll actually put a slash there and put both thermal and light. And then what kind of energy is being converted to waste energy from the kettle? So from the kettle right here, what energy is being converted into waste energy here? Yeah, you got the thermal energy that's being a lot of it. Some of it is mechanical, but it's being generated from the thermal energy. All right, so you got the girl with the bicycle that is turning the wheel, and we got our different type of light bulb here. And so what does she start out with? She starts out with chemical. And what does it convert into? Mechanical. And what does it convert into from there? Electrical. And finally, Finally, light energy, which some of it actually is lost to thermal, but not as much as the other light bulb, which actually leads you to the next question, which observe the energy produced between these two types of bulbs. What is different about the energy produced between these two types of bulbs? And circle the light bulb that produces the least amount of waste.
She needs fed.
She does need fed. So which one of these produces the least amount of waste? Yes. Generally, your LED light bulbs are a little bit more efficient than your,
They don't get as hot.
what are they? The incandescent.
The Thomas
Yeah, they don't get as hot, and they are not going to waste as much energy. All right, and last page here. Number 9 in the picture below. So you got your water flow, and then you got the fan on the end. Okay? So in this case, what type of energy do you have to start off with? Mechanical. And it is transferred into electrical, which is then transferred into mechanical. And look, I know that sometimes it seems stupid. Well, you're transferring mechanical into something else and then back into mechanical, but it's not the same form, actually. Okay, you can't power a fan with the straight faucet of water. Okay, but it has to go through a generator and a lot of times a transformer, which actually transforms the type of energy that it is. All right, last one here. So we got the sun and solar panel and the fan. Okay, so we start out with the light energy, which transfers into electrical, and then it transfers into mechanical. All right, looking at all of these types of energy that we just went through, which of these do you think would have the least amount of waste? Mechanical's pretty good. What do you think has the most waste?
Light.
I would say thermal. Okay, a lot of the thermal energy, like if you can catch the light, then it's pretty efficient. But the thermal energy, a lot of that is just lost to the air. So I would say thermal is probably your least efficient. Most efficient, I would say, actually would probably be considered electrical. Because really you don't get a whole lot of energy that's lost from there. Mechanical is pretty efficient. Yeah, but I would say your electrical energy is pretty much probably your most efficient. Because you're not really losing anything. All of the energy is being transferred into the next type, and so you're not really losing energy from the electrical form of energy. It's usually lost from other forms of energy. All right. Anybody have any questions?